Welcome to the second lecture of research methodology. In the first video, we covered the introduction and broke down some really important foundational aspects. Today, we're taking that journey a step further and diving much deeper into the actual mechanics of research. We've got a pretty packed agenda today. We're going to start by looking at the methods of knowing, then we'll untangle variables and hypotheses, figure out our data instruments, and finally we'll wrap up with the ethical side of things, avoiding plagiarism, when to paraphrase versus quote, and how to nail those APA citations. Let's get right into it. Section 1, Methods of Knowing and Research. Have you ever stopped to think about how we as humans actually acquire information, or why we accept certain things as absolute truth? It's a deep philosophical question, but it's literally the foundation that all of our research is built on. So, according to the American philosopher Charles Peirce, there are 4 main ways we gain knowledge. First up is tenacity, basically stubbornly holding on to old traditions or superstitions. Then there's authority, where we just blindly believe a recognized expert without questioning them. Third is a priori, or the dialogue method, where we reason things out through debate and logic. But the true game changer? The fourth method, the scientific method. This is where we formulate hypotheses and rigorously test them. Every credible piece of modern research is built right here on this scientific foundation. Now, when we apply this method, research generally falls into 2 buckets, pure and applied. Pure research is super broad. It's highly generalizable. Think of a massive study on employee satisfaction and productivity overall. Applied research, on the other hand, is hyper-focused. It's like taking that same concept, but applying it to solve a very specific problem at, say, one particular UBL bank branch. Section 2, Variables and Hypothesis Formulation. Think of this as the architectural blueprint of your study. This is exactly where we define what we're measuring and what we actually expect to find. Let's talk variables. A variable is simply anything that can, well, vary or change. You have your independent variable, that's the cause, the influencer. And then you have the dependent variable, which is the effect. Simply put, a change in the independent variable directly causes a change in the dependent one. In the academic world, everything starts with a question. A research question basically highlights a gap in the existing literature. As researchers, our job is to fill that gap, and we do that by creating a specific, testable statement. We call that testable statement a hypothesis. It's an intelligent, educated guess predicting exactly how the independent and dependent variables relate to each other. But here is the absolutely crucial part to remember. A hypothesis is not a proven fact. It is an assumption that you must test using real data. Let's ground this with a real-world example. Say your broad research question is a happy worker a productive worker? That's way too vague to test, so we transform it into a specific hypothesis, or H1, like this. Happier workers are more productive than unhappy workers. Boom. Now we have a clear, directional statement that we can actually go out and measure. Now you're going to run into 2 main types of hypotheses. First is the null hypothesis, or H0. This is the ultimate buzzkill. It claims there is absolutely no relationship between your variables, like saying family income has 0 impact on entertainment spending. Then you have the alternate hypothesis, or H1, which confidently states that a definite relationship does exist. Generally, as a researcher, your goal is to gather enough evidence to support this alternate hypothesis. Section 3, Instruments for Data Collection. All right, we've got our hypothesis locked in, but how on earth do we actually gather the data needed to prove if our educated guess is right or wrong? You've got quite a few tools in your toolkit here. You can use focus groups or dive into participant and non-participant observation. But one of the most powerful tools, especially if you're in business or marketing research, is experimentation. This is where you introduce a specific stimulus, completely control the environment, and measure exactly how people react. Section 4, Understanding and Avoiding Plagiarism. Once you've collected your data and you sit down to actually write your paper, academic ethics become the name of the game. The definition of plagiarism is pretty straightforward. It's using someone else's words or ideas without giving them the proper credit. It's a massive deal in academia. Why? Because it completely undermines the entire scientific method we just talked about. So let's do a quick mental test. Imagine this scenario. You copy a sentence word for word from a book, you put quotation marks around it, and you cite the original source right there in the text. Think about it for a second. Is that plagiarism? Absolutely not. You're totally in the clear. As long as you are using quotation marks and properly crediting the original author, you are playing completely by the rules. It is not an academic crime. Section 5. Paraphrasing versus direct quoting. These are the two primary ways you're going to integrate existing literature into your own research. And honestly, mastering the difference between the two is the hallmark of a truly great researcher. So, paraphrasing simply means taking the author's original idea and expressing it entirely in your own words. You drop the quotation marks, but, and this is key, you still have to credit the source. But here is a massive warning. If you just take the original text, swap out a couple of words for synonyms, and call it a day, that is still plagiarism. You have to fully synthesize the idea and restructure it yourself. There's a great rule of thumb from writing expert James D. Lester. He points out that students rely way too heavily on direct quotes. His golden rule, probably only about 10% of your final manuscript should be direct quotes. The other 90% should be your own brilliant synthesis and paraphrasing. So how do you choose? It's simple. Paraphrase when the author's original words are overly complex, or when you just need the gist of the idea to make your point. Save those direct quotes for when the exact wording is absolutely vital, like when changing even one word would ruin the impact or meaning. Stick to this, and your paper won't turn into a bloated, disjointed mess. Section 6. APA Formatting and Citations. We've reached the final mechanical step of the journey, standardizing all those credits we're giving out. When you're using APA style, the rules are pretty clear-cut. For a direct quote, you need the author's name, the year, and the exact page number, like, quote, Jones and Smith, 2002, page X. If you're paraphrasing, just the name and year will do the trick. Oh, and a fun fact, if it's considered common knowledge, like the fact that the Earth is round or the Canadian Confederation happened in 1867, you don't actually need to cite it at all. I want to leave you with a thought-provoking question today. Think about your own internal biases. How might they secretly influence the variables you choose to study, or even the subtle ways you paraphrase someone else's findings? It's kind of wild to think about, right? Great research relies on us being completely aware of these things and applying these methodologies rigorously. Thanks for joining me in this explainer, and I'll catch